All right, today we're going to multiply and divide rational expressions, okay? But before we get on that, what we're going to do, we're going to just recall there are different ways that we can multiply, okay? So first of all, we could just go ahead and multiply straight across. So that's going to give me 6 over 24. And then we always want to reduce our fractions as much as possible, okay? So what can I divide out of both the 6 and the 24? Okay. So that will reduce to the fraction 1/4. All right, final answer, we're good there. You do not have to multiply straight across and then reduce. You can reduce and then multiply. If you reduce and then multiply, that actually gives me smaller numbers to work with in the end, but you can do it however you want to. That's totally fine. Okay. Right here, I've got 3 and 6. They don't have to be vertical. They can be diagonal as long as the things are being multiplied and one's on the top, one's on the bottom. That would become 1 over 2. But then I have this 2 over 2, which would become 1 over 1. And then you still multiply straight across, and that would just give you the 1/4 in the end. I still got the same answer no matter which process I followed. Okay? Now, it does require a little bit more work when we are working with the rational expressions. Here is my recommendation. Once again, if you don't do it this way, that's fine, but this is my recommendation, okay, for the monomials. Okay? I recommend multiplying everything together and then simplifying. That's my recommendation. You can simplify then multiply. That's fine, okay? I'm probably going to do a mixture of both depending on what my numbers are. Now, with binomials and trinomials, we have to factor everything first, and then I will simplify, okay? With binomials and trinomials, or just polynomials in general, we need to factor everything we can first, and then we will simplify, okay? Now, I'm still trying to keep in mind what my excluded values are. We always want to identify those, just like yesterday, before we start canceling anything out. All right, y'all got those blanks? Okay. All right, let's take a look right here. Let's see, I'm going to grab my colors like I had yesterday. Okay, right here, I am going to simplify my numbers, and then I'll work with my variables, okay? So right here, I've got 6 over 2, and I have 10 over 18. It does not matter. I could do the 6 and the 18, or I could do the 6 and the 2, okay? Let's go with the 6 and the 2 first. That becomes 3 over 1. And do you agree that 10 over 18 becomes 5 over 6? 5 over 9. I'm sorry, golly. It's Tuesday and my math still ain't mathing. Okay? Good catch. All right, now, right here, diagonally I have a 3 and I have a 9, so that still reduces. So I want to take that down as far as I can. That will leave me with a 1, and that will leave me with a 3. Okay, so what I'm going to do, I'm going to multiply my numbers straight across, and I get 5 over 3. But then I have these like terms on the top. If I multiply the x squared and the x to the third together, that gives me x to the 5th. And then here I have y to the third and y to the 4th, which gives me y to the 7th. On the bottom, I have x squared. There's no more x, so I'm going to leave that as x squared. And then here on the bottom, I have y squared and y squared, which makes this y to the 4th. Now, what I need to do, I need to simplify my x's and I need to simplify my y's. I like to think of these as a 1-for-1 cancellation. If I have 5 x's on the top and 2 on the bottom, okay, it's a 1-for-1 cancellation, so I'm left with x to the 3rd where? On top, okay. So let's see, that becomes x to the 3rd, and that x squared just goes away. And right here, I've got 7 y's on the top, 4 on the bottom. The 4 go away, and I'm left with 3 on the top. So my final simplified answer here is 5x cubed, y cubed, all over 3. Okay? Now, if I were to ask you right here what my excluded values were in the beginning, how many variables do I have in the denominator? 2. Yeah, you got an x and you got a y. And because it's just a single variable, there's no addition or subtraction with those, we have to say that y cannot be 0 and x cannot be 0. Okay? All right, let's come to this one. All right, let's say I wanted to multiply everything straight across from the get-go. 4 times 5 is 20. I'm going to have a to the what power up top? 5th. All right, and b to the 8th. All right, let's see. 15 times 12 is 180. And then I will have a to the what? 5th, because that's an understood 1 right there. And then I'll have b to the 10th. Perfect. All right. I'm actually going to change colors with my reductions right here. Okay. Now, 20 and 180. What does that become? 1 over 9. What happens with my a values right here? Everything cancels out because it's a 1-for-1 cancellation. And then I have these b's that I need to work on. I have 8 on the top and I have 10 on the bottom. So what happens? You got b to the 2nd where? On the bottom. So my final simplified answer, all I had left in the numerator was just a 1. And then I have 9b squared. That is my final answer. And once again, because I had 2 different variables in the denominator, okay, and they were just individual variables, okay, there's no addition or subtraction with those. We just have to restrict those variables from being equal to 0. Well, 8 minus 10 gives you a -2, right? But if you want to get rid of a negative exponent, you drop it to the denominator. So either way you do it, yeah. Okay? All right, now, notice I have 2 rational expressions multiplied together, okay? We need to be very careful as we work through these, all right? We need to factor every single piece, numerator and denominator, as much as possible. Aiden, eyeballs, babe. Okay, here we go. I am going to, in the numerator, I'm going to take out a GCF of 4x. What does that leave me with inside parentheses? X minus 1, okay? That's that numerator. Now, in the denominator, I see that there is a GCF of 2. So if up here, if I go ahead and I take that out, I know that I'm going to have a GCF of 2 down here, but what are the factors of negative 3 that add up to give me positive 2? Positive 3 and negative 1. Perfect. Okay. And then up here, I want to factor this trinomial. Okay. What 2 numbers multiply to give me negative 6 but add to give me positive 1? 3 and negative 2. Good. All right, and then down here in the denominator, I have a GCF of 4x. And that left me with an x plus 2. Okay? Now, before I cancel any of these out, okay, I want to go ahead and I want to identify all of my excluded values, okay? Do I care about this 2? Why not? It doesn't have a variable. Okay, so I'm going to go to the next one. I know that x cannot equal negative 3. The next one, x cannot equal positive 1. What about this 4x? 0, good. And what about this plus 2? Negative 2. So I had 4 excluded values right there. So remember, we don't care about anything if it doesn't have a variable, okay? All right, now let's go through and let's see what we can get rid of. It has to be on the top and bottom in order to cancel it out, okay? What do you see? Okay, you can divide out the x minus 1s, the 4x, the x plus 3s, and that's it. Why can't I do anything with those? The signs are different, right? They have to, the whole group has to be exactly the same. So my final simplified answer for this multiplication problem is x minus 2 over 2 times x plus 2. Okay? All right. Now, the first thing I'm looking at on this, I don't like this numerator. This is like that situation from yesterday. What are 2 problems with this? It's backwards. The order matters. And what else do I not like? The negative out front. Okay, so I flip-flop this around. And what is my GCF here? Negative 5v. Okay, so when I divide out a negative 5v, I've got a v minus 2. All right, how does my denominator factor? Negative 9 and negative 2. Good. Helps if I put the right variable. All right, what about my numerator's factors? Negative 9 and positive 1. Good job. And then can I do anything with that denominator? Nope. Okay. So just like yesterday, I factored. The second thing I need to do is identify my excluded values. And here I want to list all the things that v cannot be. Hayden, wake up, babe. All right, can't be 9, 2, or 0. Good. All right. What are the easy things to cancel here? Okay, the v minus 2's go away. V minus 9. Okay, the v goes away. Perfect. So that becomes 1 over 3. Check me on that. Y'all know my reduction skills are not real good today. Okay, am I good? Okay. Now, I've got this negative 1 up here. Don't forget that negative sign, because that negative sign belongs to the v plus 1 that was left over. And all I have left in my denominator was that 3. You could have given that negative down to the denominator also. Either way is totally fine. I'd give you full credit. Yes?
For the EBS, whenever it's the b plus 1, could it also, for the EBS, it would be minus 1 in it?
So you're talking about?
Yeah.
Okay. So we only care about the denominators for those. Yeah, that's fine. Okay? All right. Let's keep going. All right, I don't like this denominator. So I'm going to flip the order around. Okay? My numerator stays exactly the same. I can't do anything to that. But my denominator, I can factor out a negative 1. That leaves me with positive p minus 9. Okay? And then I want to think about the numbers that multiply to give me negative 36, add to give me negative 5. Do what?
Negative 9, positive 4.
Perfect. Negative 9, positive 4. And then down here I have a GCF of 4p. That leaves me with p plus 4. Okay, everything is factored completely, okay? So I'm going to come down here. I'm going to identify my excluded values, and that's just looking across the bottom right here. Do I care about that negative 1 out front? Nope, because there's no variable right there, okay? So right here, I got 9, 0, and excellent. Okay. I can cancel out p minus 9. I can cancel out the p plus 4s. And that's it. Okay? So my final answer, I've got p plus 10 over, don't forget that negative 1 out front, negative 4p. Okay. Then I get to these right here, okay? These are going to require a little bit more work to factor, but we're going to do them together, okay? Right here, I am going to, first of all, I'm looking for GCFs. Okay, guys, I need your attention. Okay, I'm so sorry you're tired. I'm tired too. This weather does not help, okay? But you got to stay awake and work with me. This is where I got to do my X method, so I'm going to slip and slide, okay? 6 times negative 63 gives me negative 378. And I need my factors to add up to give me 13. Now there is a very quick way that I can determine what my factors are. Right here, if I go to my y equals, okay, and I type in 378, I'm keeping in mind my signs, and I divide that by x. So 378 divided by x, and I go to my table of values, so second table. Right here, all of these that give me pretty numbers, those are my factors, okay? So I want to find a pair of numbers with one of those being negative that I will get a positive 13. Look at that. You got 14 and 27. Will that give me a 13? So I'm going to put 14 here. I'm going to put 27 there. Which one has to be negative? Perfect. Now, 6 and 14 have a common factor of 2. So that leaves me with 3 over negative 7. And 6 and 27 have a common factor of 3. So that leaves me with 2 over 9. Okay? So right here, this gives me 3c minus 7 times 2c plus 9. That's the numerator. Now we got to go to the denominator. Okay? I'm going to slip and slide again. I'm going to do another x. 6 times 7. 6, 7. Okay? Right here, I got 42. And I need a sum of negative 17. What do you get? Okay, I need the factors of 42. So here I could delete the 378. I can put the 42 in. Look at the x. I need them to multiply to give me a positive, but add to give me a negative. So both of them have to be negative. I got 3 and 14, but they both have to be negative. Negative 3 and negative 14. 6 and negative 3 have a common factor of 3, so that gives me 2 over negative 1. And 6 over negative 14 give me 3 over negative 7. So 2c minus 1 and 3c minus 7. Okay, I got one more to slip and slide with. I've got this numerator. 2 times 4 is 8. And I need that sum to give me negative 9. This one should be a lot easier. Should be negative 1 and negative 8. The only thing that reduces is the 2 and the 8, so that's 1 over negative 4. So 2c minus 1 and c minus 4. What can I take out here in this denominator? A 6. That leaves me with, let's see, 54 divided by 6. Yep. Okay, that gives me 2c plus 9. Thank you. All right. That took a little bit longer just because I had more factoring processes to do. Okay. But now I want to identify my excluded values before I cancel anything out. If I set negative 2c equal to, or negative 2c minus 1 equal to 0, positive 1 over 2, I'll have positive 7 over 3, and negative 9 halves. Why not 0 here? Because that 6 doesn't have a c value. Okay? What cancels? We got 3c minus 7, 2c plus 9, 2c minus 1, and that's it. So I have c minus 4 over 6, and I'm done. Please, 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 y'all. That does not become negative 2 over 3. Remember, that c minus 4 is protected, okay? It is protected. So we factor, we find excluded values, we simplify, okay? Let's talk division, okay? Let's talk division as soon as okay, now, right here with division, okay? Division, right here, I am still going to go through and show you these two examples different ways, but when I am dividing, please remember that we keep the first fraction the same and we multiply by the reciprocal. Okay, so right here I'm going to change this to 6 over 2. So same thing over here, 3/4, and I'm going to change that to 6/2. All right, you can multiply straight across. That gives me 18/8, which reduces to 9/2. Or we can reduce and then multiply. Right here, 6 and 4 or 6 and 2, it doesn't matter. That has a common factor of 2, so that gives me 3/2. That's all I can do, so when I multiply straight across, that should have been a 4. Okay? That should be 9/4 here also. Okay? See, I caught myself. All right, now, typically, and when we say this, I need y'all to understand that all I'm saying here is that I'm multiplying by the reciprocal. We often say keep, change, flip. But the flip is referring to that reciprocal. Okay? Keep, change, flip. All right, so over here, I'm going to keep this first fraction the same. And I am going to multiply by the reciprocal. So this 8q to the 5th is now my numerator. And 35p squared q squared is now my denominator. I personally recommend simplifying your numbers. Okay? So right here, 5 and 35 become 1/7. And this 8 and 16 become 1/2. So when I multiply those numbers together now, I've got 1/14. I end up with p to the first power, q to the 6th, and then in the denominator, p to the 5th, q squared. And now I want to reduce those. Okay, my fraction still stays the same, but here 1p cancels out and leaves me with 4. Here the 2 q's on the bottom go away, and here I'm left with q to the 4th. So my final simplified answer is q to the 4th over 14 p to the 4th. Now, as far as my excluded values go here, notice here I'm kind of waiting till the end because no matter what, I still have a p and q happening in your numerator denominator, okay? So p nor q are allowed to equal 0. All right, but what I want you guys to see, and I'm going to point out right here, this 8q to the 5th was my original denominator, but once I wrote the reciprocal, this 35p squared q squared was my denominator. So when I am identifying my excluded values for division problems, you have to consider every denominator that there would possibly be from start to finish to identify excluded values. Okay? All right, here we go. Right here, I'm going to write 10 over. I'm going to factor out a GCF of this first denominator. That leaves me with an x minus 2. Okay? And I'm going to multiply by the reciprocal. So this 2x squared plus 6x is now my new denominator. But what can I do to factor that? I can just take out a 2x. That leaves me with an x plus 3. And then what does this factor into? Should be x plus 3, x minus 2. Okay, now when I'm identifying my excluded values, I need you guys to remember that this was my original denominator, and this is now my denominator. I have to consider all 3 of those locations for my excluded values. Right here, x cannot be positive 2, x cannot be 0, x cannot be negative 3. If I come up here and I look at these also, do you guys agree that I already had the negative 3 and the positive 2? So you don't have to rewrite those. But we did have to make sure we had everything we needed. Okay? So what can I cancel or what can I reduce? The x minus 2's, the x plus 3's. Is that it? No. You can do 10 over 4. Okay, 10 over 4, you divide out of 2, so that's 5 over 2. So if I multiply straight across everything I've got left, all I had in the numerator was a 5, and all I have left in the denominator is 2 times 2x, so 4x. Okay? All right. Let's keep, change, flip, and I'm going to factor all of it at the same time. Okay? Right here, what can I take out on the top? A 2 and an a squared. That leaves me with a minus 6. My denominator factors into negative 6 and positive 2. Good. Okay, I don't like this right here. Okay, first of all, that's going to change places. But I don't like the order of that. So I'm going to rewrite it right here very quickly. Okay, this goes to the denominator. But in doing so, I'm going to factor out a negative 8a squared. That leaves me with a positive a plus 3. And then how does this factor right here? Negative 5 and negative 3. Okay, so right here, we know a cannot equal 6. It cannot be negative 2. It cannot be 0. It cannot be negative 3. These are my denominators, right? But this was my denominator, so I've also got to consider that. So a cannot be 5 or positive 3. I'm just going to come in here and write plus or minus 3. That's a lot of excluded values, but that's okay. The easy things to cancel out, I've got the a minus 6's. The a squareds go away, right? And then the 2 and the negative 8 becomes 1 over negative 4. Is there anything else? Nope. Okay, so let's see. I have a minus 5 times a minus 3 over negative 4 times a plus 3. Okay? All right. Notice I've got multiple things here. This is the only thing that follows division, though. Huh? Oh, yeah, shoot. Times a plus 2. Good catch. It's clearly right there. All right. Right here, I need to write this as a fraction. Okay? I need to write that as a fraction. So when I am factoring and I'm getting all of this set up, okay, the only thing that changes to the reciprocal is anything that follows a division sign. So I've got 1 over 4k plus 1. And then this right here doesn't change. Back here, this is 4k plus 1 times 4k minus 1. And then you've got the k plus 3 down here in the denominator. What can k not equal? 0. Negative 1/4. And negative 3. Now, right here, this is what followed the division, right? So I would also have to consider that one's numerator, but there's no variable there, so just pass over it. Okay? Let's see. I have the k plus 3s that cancel, the 4k plus 1s, and that's it. So 4k minus 1 over k. Please do not cancel out those k's. All right. Right here, I would write that over 1. I'm not going to work this out. Okay? Right here, on this one, what do I not like about the numerator? The order, right? H squared plus 1. And I also don't like the negative 1. That turns that into h squared minus 1, which is a difference of squares. Yeah, I said I wasn't going to factor that other one. Okay, so that numerator becomes negative 1 times h plus 1 times h minus 1. All right, now right here, this has a GCF of 2 that I can divide out. That leaves me with h squared minus 5h minus 6. And that factors into h minus 6 times h plus 1. And then I multiply by the reciprocal. 6 goes in the numerator. Hayden. I'm going to factor out a GCF of 2 down here. Okay. So what can h not equal? 6, negative 1, and positive 1. Okay? So I've got h plus 1s that cancel. I have h minus 1s that cancel. And right here I'm going to work with this 6 and 2. That gives me a 3 over 1. When I multiply straight across, I get a negative 3 in the numerator. And then I get 2 times h minus 6. Do what, babe? Okay. The rest of this, you don't have to do, okay? But I do want you to know that there are extra practice problems if you need to come to tutoring, all right?